Today we're going to be investigating how an object's moment of inertia and size affect how quickly it can roll down this slope without slip. We're going to have three different types of objects. We have spheres, cylinders, and rings. Each of them have a different moment of inertia, and you should be able to predict which one will roll quickest down the slope. First test was the ring versus the cylinder. As you can see, the cylinder rolled much faster than the ring. Next, the sphere was put against the ring. And the sphere did about the same as the cylinder and beat the ring. Now the cylinder and the sphere race. And it's a little closer, but when you look back, and you can see it easier in the slow motion, the sphere does roll faster than the cylinder. Next, we will roll the objects against scaled versions of themselves. First, we will have the spheres. The spheres roll at almost exactly the same rate. Now, we roll the cylinders. The cylinders were even closer than the spheres. Finally, the rings. The rings had a bit more of a pronounced difference, because they are not actually scaled copies of each other, as the thickness in both is the same.
Now that we've seen the results, we should be able to form an explanation for what happened. A convenient notion for this is that of the radius of gyration, or k0. As k0 increases, so too does an object's moment of inertia. You can see the radius of gyration for each shape on screen now. From this notion, as well as the conservation of energy, we can derive an expression for the final velocity of the object that varies only on the height of the slope and the radius of gyration of the object relative to its outer radius. As you can see, since all the shapes k0s are in terms of r, the radius will cancel out in the final expression for velocity. This means that an object's speed down the slope is independent of its size, which is exactly what we have observed. Also, as k0 increases, the velocity will decrease. This means that objects with higher moments of inertia will move slower, which is also what we see. The ring is the slowest with the highest moment of inertia, the cylinder is somewhere in the middle, and our fastest object is the sphere, which has the lowest moment of inertia of any of them.